This is a small introduction to fault finding in a PA system. I've done it mostly for my own team at the church I attend, but it's a general purpose fault finding as well, so it should be of general benefit to people, though there are a few specifics that I'll bring in that relate directly to the situation that my team has to work with. So what is fault finding, and how do you start tracking down problems? Well, the first thing is you need to think about signal tracing. Signal tracing is the path by which the signals go from the person speaking or the instrument playing all the way through your system to coming out either on from a loudspeaker or a pair of headphones. So you need to think about the entire path, because if anything's broken in that path, then you won't get the sound coming out. So starting at the front here, you have a microphone. The microphone obviously has a capsule, has a switch, sound comes in there, it's then connected via a mic lead. That for us goes into a floor box. The outputs from the floor box go from the front of the church to the back of the church where you have a patch panel, and then the patch panel is connected to a mixer, and inside the mixer you might have a mute switch, you've got a variable gain amplifier, and the output from the mixer goes either maybe to a pair of headphones or through an amplifier to the loudspeaker. So if anything is wrong in that path, then you won't get the sound coming out. And some of it you can actually check straight away. So for example, that microphone's not working. Are you sure that these things at this end, in terms of the mixer and the amp, are working? So if you played music from maybe another channel, does that come out of the amplifier and the speakers? Is the amplifier actually on, for example? I'm not going to concentrate too much on the mixer end the side of things, because generally most people have maybe a different mixer or different setup from there. I'm mostly concentrating forward of that. Yeah, don't forget that the problem could be in the mixer itself, but always, if possible, try and find that out by maybe proving that this end of it is working. That should be quite easy to do. So what are the strategies for signal tracing? Well, the first strategy is probably configuration. You've possibly made a mistake in the configuration. In that case, inspect and correct the mistake. It could be possible that the mic lead is in the wrong floor box port. It could be working, but just going to the wrong place. Patch panel could be wrong. So there's a few things that you need to look at. Understand how things work, and if that's the case, inspect and correct your mistakes. So that's the first strategy, of understand your configuration and check that you're actually configured in the way that you are. It could be that you've got a failure in there. In that case, look at substituting it for a working item. So for example, you look at this and you go, oh, I think it might be my mic lead. I swap out the mic lead, put that in, swap out the mic lead for that, and then it works. Great, you've substituted a working item. Clearly, some of these things are easier to substitute than others. Most of us probably don't have a spare mixer sitting around of identical types. But you've probably got microphones, you've got leads, those sorts of things. Try and substitute them in. And finally, which is a bit that people often forget, that you actually need to confirm that did you really fix it? Did the item that you think has failed really fail? For example, going back to our microphone lead, it's the heat of the moment, you're trying to get going up. I know the pressures of, the band want to practice and you can't get the lead singers through the mix. You swap out the lead, great, that's fixed it. Don't then at that point just throw that lead in. Don't throw it back in the pile if it is broken. That's really not good news. But also don't just throw it away at that point. Always at the end, when you've got a bit more time, when the band are finished and you're clearing up, go back and just go, did I really fix it by doing that? So for example, you substituted a lead, new lead works fine, great. Go back and actually test the lead. Is the lead as defective as you think it is? Because it's entirely possible that by changing, say, the mic lead, you might actually have a problem in the floor box. It could be that the floor box has a loose connection in it, and just by changing the lead, you've temporarily fixed it. But it could come back and bite you afterwards. So, after the event, sit down and go, well, what did I do to make that work? And really, was it that? Because that way you'll find maybe some latent fault that you didn't think that you had in there. I'm going to talk a bit about the patch panel now, because the patch panel and this is going to be our setup, the church I go to, but other places have patch panels as well. So what actually is the patch panel? Well, basically, all of the inputs and the outputs of the mixer appear on the patch panel. And in our patch panel, it's normally the second row where they're paired up. So there's a list of them there, and there's a list of them through there as well. So, but it's mostly, to be fair, the top panel up there. So all of the patch panels come into there. As well, all of the feeds from the floor boxes go via the patch panels. So in ours, they're all labelled up with a letter and then a number that relates to the socket that's in the box that's there. And for us, it's a really convenient way of actually connecting floor boxes to the mixer. Now, when we put this in, we had an analog mixer. With new digital mixers, it's a bit easier because you can easily, the slider doesn't necessarily have to correspond to the channel on the desk. But typically, we've still carried on to a large degree thinking of it in an analog sense. So, for example, the input 1 ends up on line 1 on this one, and so forth through. It just makes a bit easier to see what's going on, and because we'd configured like that in the first instance, it made sense to carry that on. Fully recognising I could easily change what slider 1 is. Slider 1 is typically channel 1, slider 2 is channel 2, and so forth. So that's what a patch panel is, but how does it actually work? Well, there's something called normalisation in a patch panel, and the idea is that normally, hence the term, that the two channels are connected together. So over here, for example, normally channel A1, which is floor box A, socket 1, is connected into desk input 1. There's no jumper between those two because behind the scenes, inside the patch panel, those two are connected together. And in our case, it happens to be that A1 is connected to the piano. So hence A1, piano is connected to desk input 1, and that's the one we normally use for a piano. But that's if you've got nothing connected. Now, if you plug into the lower socket of a vertical pair, in this case the one's going to the desks, then the upper socket is disconnected. So if I connected a patch lead into input 1 here, the piano would no longer come through. That one would be disconnected. Now, we've got something called half normalization, and which means that that doesn't apply if you plug into the top one. So if you actually plug into the top socket, the channel from there still goes down to the input 1 down here. So what that means is you can actually send the same signal to two places. Now, we do that with our singers, our worship leaders radio mic. Normally, worship leaders radio mic for us is normally on channel 2, or UHF2 as it's labelled here, and that goes into desk input 18. But in this case, we've put a batch panel into the output from that. That still goes into the channel 18 on the desk, but also via this patch lead, I've plugged it into desk input 9. Now for us, by tradition, desk input 9 is actually the first vocal singer, first vocalists. So basically I can put it through the desk twice. And why do I want to do that? Well, when the worship leader's singing, they want different settings to when they're actually leading worship and speaking. So for example, they don't want fallback when they're speaking, but they do want fallback when they're coming in as singing. The singers normally get a bit of reverb putted in. We don't want that when they're speaking. So by using the patch panel like this, we've actually connected them in twice. Sounds a bit complicated. Generally, it's set up and we've got a sheet on the top of our desk which actually explains the normalization we use. But that's just how our patch panel works there. Let's go back to fault finding. So let's look at microphone fault finding. So you've seen this diagram before. You've seen the path that's going through. What are the first things I would actually check for? Well, the obvious one is actually a lot of our microphones have got switches on. Is the microphone actually on? Now, normally the singers are quite good and we teach them to, when they bring the mic up, to push the switch. But often we use the same mics for, say, a couple of drums, occasionally gets pressed into service. Did you remember to turn the switch on? So that's an obvious one. The next one I would look at is the microphone cable actually in the right floor box port? Because that might be different. Go and double check that. again, I normally try and label up the floor boxes, and I normally, because a lot of our stuff can stay there between services, I normally label up the cables so we know which one it is. So, is the floor box plugged in the right place? Equally, on the patch panel, is the patch panel up correctly, and is it going to the right port on the mixer? A couple of our singers, sometimes we normally put them all down one side of the stage. If they get split on the other side, or you've got, as we've seen previously, a radio mic being doubled up, that might require a check on the patching. Other bit, so we've got that. Obviously, the mute switch is very obvious on the desk. It's a big red light, but is the gain on the mixer correct? Has someone turned the mixer gain down? That's why you can't hear them. Or more worryingly, have you got to turn the gain all the way up to hear them at normal volume? That is also something you should watch for, because in our desk, most singers' vocals are around about the 37 to 42 dB gain for our setup. If it's massively different from what is the normal, or massively different from another person's channel, there's a fault somewhere. So it's worth stopping and having a look. But obviously, that's there. The other bit as well is, does the microphone need phantom power? So what is phantom power? Not all microphones require power, but some do. So dynamic microphones, which are moving coils, don't need power. They don't need a voltage to work, because basically there's a magnetic diaphragm that couples into a coil that acts as a generator, and it makes its own voltage. So dynamic mics we normally use for singers' mics, and we also use them for close coupled drum mics. So on our drum kit, things like the kick, the snare, the tom, they're all dynamic microphones. They do not need phantom power. However, there's a second class of microphone we use called condenser mics. Now, they need power because they're actually effectively a capacitor in there, or condenser in old stores. And to make them work, they have an integral preamp, which is generally supplied by phantom power, which puts 48 volts DC from the mixer into the XLR connector and then into the microphone. So the microphone is powered from a clean 48 volt DC support and uses exactly the same cabling. So it's all integral. So what are condenser mics we use? Well, in our church, we use them for the piano mics, we use them for the overhead drum mics, we use them for pulpit and stand mics, we use them for the ambient mics, and occasionally we use them when we've got a couple of other mics that for speaking parts. The 48 volts is actually turned on by the preamp screen. In our church, we've got an Allen Heath SQ7, and if you go into the preamp section, you'll find there's a button for 48 volts. In ours, on the touchscreen, you have to hold it down for a couple of seconds, then it comes on, so you don't accidentally toggle it on and off. So, is the 48 volts turned on? This is really a part for my own team here. We also have some woodwind mics, which are condenser mics, but they use an AA battery in a pack. They are turned on by plugging a mono cable, and it has to be a mono jack, into the output connector on there, and that then turns the microphone on. The batteries in there last forever, but if you suddenly find that they've gone deaf, there's a good chance that the battery finally needs replacing. So you turn it over, undo the 4 screws, and you'll see the AAA battery inside. Under no circumstances put phantom power into these microphones. They really won't like it. So that's just one about our woodwind mics. So that's microphones. What about guitars? Well, I've simplified the diagram here because I'm not going to say about the mixer side of things and the patch panel, because that's common to every source that we've got. So typically with us, if you've got an acoustic guitar, that's connected via jack to jack lead. That goes into a Marshall amp that we keep on the stage. That goes in the guitar in. There's a line out connection on the back, which goes into a jack to jack lead via a DI box. And then there's another XLR lead to the floor box, and then patch panel and amp, etc. So what would I check if I wasn't getting any sound? Well, the first thing I do is actually check to see if there's any sound coming out of the amp. We don't have this particularly loud. It's more acting as a bit of an interface for us. But it is there. So if there's no sound coming out of the amp itself, then basically something either in the amp or the guitar isn't working. So what I would do, I would check if it's an acoustic guitar or electroacoustic guitar, it will have a battery in it. So check that the battery's live. Guitarists have a habit of never bothering to check this. Check that the volume is up on the guitar. Obvious, sometimes forgotten. If that's all good, check out the guitar lead. Try a replacement or try testing it. And also check the amp settings. You know, the amp could actually be turned down to 0, and there's a number of volume controls on amp. There's an initial gain stage here for that channel, then there's a master volume as well. So just check that that's going. Get the sound coming out the amp. So if the sound is coming out the amp, you found that one, but it's still not coming out the desk, well, the next thing is to check the lead to the DI box. After that, check that the DI box is actually on. I'll talk about a bit more of that in a minute. But basically, there's a flashing LED on here, and you've actually got the settings correct. If that's still not right, check the XLR lead and check the floor box. Just one slight thing with these guitars, we do have a ground switch on the amp. If you've got a loud hum on the channel, there's a bit of a fault like that, actually go and have a look at the ground switch and toggle it between lift and ground and see which one is better. There's no hard and fast rules on what's right with that. For an electric guitar, it's very similar. Generally, electric guitars don't have a battery in them, but other than that, it's basically the same. So a little bit about the DI boxes. We've got 2 DI boxes we use. First off is a Behringer DI20. Not the greatest DI box in the world, but quite inexpensive and quite rugged. It's fine for anything other than a very low level source, so I wouldn't plug a guitar straight into this. And actually, for one of our guitarists, when they use his electric amp, that actually doesn't like it as well. But as a general purpose thing for line level sources, this is fine. So just a couple of quick things on it. Firstly, it's powered by a PP3 battery in the back. If you've got low battery, then the LED stays on permanently rather than flashes. So if it goes permanent, swap this out. We keep a few spares up at the desk and put a new battery in it a bit later. You can actually power this on phantom power in emergency. I wouldn't recommend it, but you can do. Set the attenuation at 0. The only time you'd ever move that is if for some reason you were maybe taking a speaker output into it and needing to push that down. Mode, we very rarely use this. You can have it in either 2 channels, so you can have, if you had a stereo source, you can put left and right into those. Alternative, you link them, you can also get the output, you can get the output from that one and that socket as well, or you can daisy chain between them. They parallel those up. Very rarely used. The other thing to remember is at the end, switch it off, because you can guarantee the battery will be flat after a week of not being used. So that's the Behringer DI20. Another active box we got is a Chord Active DI box. This is actually a better quality box for low level sources, again powered by a PP3. This has a low battery light that comes on. So if that light comes on at all, it means the battery is about to discharge. Not the most helpful of logic, to be honest. It can use phantom power, but again, unscrew that, get the battery out of there, and there's a little plastic bag to cover up the clips. You can run it on phantom power that way. This one doesn't have an on-off switch. Basically, it turns on by plugging a mono jack into the input. So remove that when it's finished. The through literally gives you a copy of that if you needed to daisy chain it. Again, pad, same as attenuation, I'd leave it on 0. And ground, you've now got 3 options of lift, float or ground. Again, choose the one that actually stops the main loop, the mains hum the best. So that's guitar. We've also got a bass amp in church, very similar. This one it's got a balanced out on the Marshall amp that we used, so we don't need an extra DI box. So again, is there sound coming out of the amp? So there might be a battery in the guitar. Not always, but sometimes. Check the volumes and the lead and the amper settings are all correct. Obviously check the leads as well. And again, there is actually also on that amp a ground switch on the amp as well, which you can actually do if you get hum on it. So that's the bass, very similar to a guitar. So the keyboard is very similar to the others, but we use a passive DI box on this one, so it doesn't need any power, because it's a nice big signal. And it's actually acting as a go-between. So there's actually a small wedge speaker that we use so the keyboardists can actually hear their notes and hear what they're playing themselves. So here the keyboard goes into one side of the DI box, and we use the through connector to actually power the wedge speaker that's by it, and then XLR back to the floor box. So again, start from the beginning. Is there sound coming out of that amp? If not, check the volume on the keyboard. It wants to be about 75%. Check that there's power to the amp that it's on, and actually check that the volume on the amp is as well. And obviously, if not, check the cabling. Again, if that works and you're still not getting it, I would check the XLR to the floor box, check it's in the right port. If you've got loud mains hum, again, there's a ground switch on the DI box. And also, I would check the attenuator settings on the DI box. If you've signed that I'm hearing something but it's too quiet, then if the keyboard volume itself is about 75 max and it's too quiet, there's a good chance these attenuator buttons can be pushed in. Show that in a bit more detail. As you can see on the front here, it's got some lovely push buttons. The filter gets a bit of high-end, that's not really worth worrying about. But the two attenuator buttons can be accidentally pressed in. So if it's a bit quiet, press those to see they're okay. Again, the input and input through are in parallel. We use them to drive the local wedge. If you've gotten them around the wrong way, it doesn't matter. And there's a ground lift switch on the back. So that's a bit of fault finding of some common items. Next item I'm going to talk about is actually the use of a tester. Now, the Behringer CT100 tester is a phenomenally useful piece of kit. It has two main functions. It's first off, it's a test tone generator, so you can guarantee you can always make a test tone, and it produces them at different levels. And it's also a cable tester as well. Really useful piece of kit. If you haven't got one of these in your kit, then well, go and buy one. They do a bigger brother called the CT200. I've got one of those as well. I prefer this one. It's a bit more obvious than some things. But I'm just about to go another segment, and I'll show you that in action in a minute. So here we have the Behringer CT100 tester. It has two roles. It can be a cable tester and also can create test tones. So you basically have different connector types. You have XLRs there, you have jack plugs there, you have 1/8 inch jack plugs there, phonos there. You can also test MIDIs, but only 3 pins, and has TTs, which we don't use. So in order to use the device, it's quite simple. You plug in, so in this case, an XLR to XLR cable, plug between them, and then put it into cable tester mode. And then, as you can see, there's now a pattern on there. So pin 1 is connected to pin 1, pin 2 is connected to pin 2, and pin 3 is connected to pin 3. There's also an intermittent selection here, which will light up as you put the cables in. You can reset those, and then it gives you a chance to find maybe a dodgy cable. So if you had a cable with a dodgy short on it, you could actually go and shake the cable, and if that made a shorter turn, it would appear on the intermittent. So it's really good for if you've got a slightly dubious cable. Let's remove the XLRs, and now let's replace them with a pair of stereo jacks. So 1/4 inch jacks. Stick one in the out, one in the in. Press the reset. Oh, slightly different there. Oh, great. So what we had, that wasn't pressed in properly, but we've now got the same. So it's now sleeve to sleeve, tip to tip, and then ring to ring. So that's good. Take those out. And we'll now try a pair of mono jacks. Put those in. Hit the reset. Now you've got a different pattern. This time we ended up with a 5 dice-like pattern on there, and that's because we've actually got mono connections. So pin 1, the sleeve is connected, pin 2 is connected to the tip, so that's the same. But when we have pin 3, there isn't a ring, so the pin 3 is connected to the sleeve, and hence you end up with this pattern. Let's take those out. We'll now try a mix connector. So one end of it is an XLR, and the other end is a stereo jack. Put that in there, hit the reset, and again you can see that pin 1 is connected to the sleeve, pin 2 to the tip, pin 3 there. So we can actually connect different cables of different varieties and test them as well. And that goes across all of the connections on the box. You can also use it in installed cable mode. So here you turn it on by holding down the reset button, and therefore if you had an installed cable, like a cable from front to back, if you put a short at the other end, you can see those shorts in there. So that's what the cable tester does. Okay, I'm now going to show you how to use it as a test generator. So I've got an XLR lead here which goes back to our mixer at the back of the church, which you can see the remote control of, and that's in Vocal 4. So I'll plug that into there. It can also work on phone on the jacks as well. If we turn it on to test tone mode, turn it on at test tone, you'll now see, when we do so, that we've now got a signal appear on Vocal 4 at the back. So that now proves that we've got a signal coming from here all the way through the cabling, through the floor box to the bit at the back, and it's working. And you can toggle it on and off to prove that. The box also can test for phantom power. Those two lights there light up. So let's turn on the phantom power on the desk by just turning it on from here. So we've got 48 volts here, and you now see those two lights have come up. Do be careful though, because it won't necessarily turn itself off after you've turned the phantom power off. So we've turned the phantom power off on here, but we've still got the lights on the tester. That's because there's a capacitor in the desk, and that's holding the voltage up. So what we need to do is discharge that voltage. Easiest way to do that is use a microphone. So I've got a dynamic mic here. I'll plug that in. And now plug that back in there, and as you can see, the lights have now come off. So that's the way of actually discharging that. You also have got some line levels. So at the moment it's on -50, which is matched to a microphone. I can click it up one more, which is to -10. As you can see, that is really saturating the desk, and I really wouldn't want the headphones on when that was happening. There's actually a higher level as well, but frankly these two are good enough. As you can see, it's dropped back down to there. So I normally use the -50 for that, and the -40 for line level. So that's a good introduction to the CT100. So just to wrap up how you'd use the CT100 in reality. So we go back to our initial case of having a microphone, mic test leads, floor boxes, etc. I will probably start from the stage end, to be honest, because that's normally where the problems are. So what you could do, for example, is take the CT100, put it into test tone mode, and then replace the microphone. So take the microphone out of it, plug the CT100 into that lead, and see whether the sound gets through. If the sound doesn't get through, I would probably then grab another mic lead, stick it in the floor box over here, where that one was, and put the CT100 on the end of it, and again see whether it is. That way it proves whether that mic lead is working or not. Beware though, it's possible sometimes that the real problem is the floor box, and you've actually just disturbed the connection, and you've just made it a bit better. So what I'd probably do is then use the CT100 in cable tester mode to actually test out that mic lead that I've replaced. If that mic lead is fine, then it's probably a dodgy connection in the floor box. I would then probably try and put that lead back into the floor box and see whether that still works. If I'm really suspicious about it, I'll use a different channel. If for some reason that still doesn't work, I would probably then use a different channel, see whether that worked, and then go back and see whether it's the floor box. Alternatively, I'd go over to the patch panel, and you can use the CT100 maybe in cable tester mode to actually do a test from there by putting a short into the appropriate floor box point. That's something you do in slower time, because really, to start with, you're just trying to get it working for the service. So you can test out that bit as well. Alternatively as well, you could also go, if you're really stuck, let's put the CT100 as a signal tester, signal source, into the patch panel and see whether it turns up through that chain as well, just in case you think you might have a problem with that cable, or maybe even the patch panel. The patch panels occasionally fail. So that's hopefully a helpful introduction to PA testing. Hope that's a benefit to you. If you find it interesting or want to leave a comment below, please do so. Thank you very much.